Welcome back. In this chapter, we're going to be covering problem solving and creativity. So let's get started. All right. In this chapter, the main themes will be the types of problems that we tend to face, the stages that we go through in problem solving, and in those stages, one of them is generating solutions. And I wanted to point out that we're going to be talking about algorithmic solutions, heuristics, and insight. Then we'll talk about some typical problems with problem solving, some obstacles, and then we'll wrap it up with a brief treatment of creativity. All right, I wanted to start by having you take a little survey. You can either play along with me, grab a piece of paper and a pencil and actually answer the questions, or you can just kind of follow along. It's more fun if you play along. All right, I'll assume that you paused me and you're ready, or you're just going to watch. Here we go. Okay, so here's the scale that you're going to use as you make your judgments for each item. So you're going to use the 1 to represent a response that is indicating that this behavior is very uncharacteristic for you. The number 3 will represent that it's neutral. Sometimes you do it, sometimes you don't. It's kind of characteristic of you, it's kind of not. And 5 is that it's extremely characteristic of you. The 2 and the 4 should be used for intermediate. So it's more uncharacteristic than characteristic, but it's not extremely characteristic. And it's more characteristic than not characteristic, but it's not extremely characteristic. And so use all your numbers at will. Here we go. So number 1, I would prefer complex to simple problems. I would prefer complex to simple problems. I like my problems complex. I like my versus simple problems. I like to have the responsibility of handling a situation that requires a lot of thinking. I like to have the responsibility of handling a situation that requires a lot of thinking. 3, thinking is not my idea of fun. 4, I would rather do something that requires little thought than something that is sure to challenge my thinking abilities. 5, I try to anticipate and avoid situations in which I may have to think in depth about something. 6, I find satisfaction in deliberating hard and for long hours. 7, I only think as hard as I have to. 8, I prefer to think about small daily projects to long-term ones. I like tasks that require little thought once I've learned them. 10, the idea of relying on thoughts to make my way to the top appeals to me. 11, I really enjoy a task that involves coming up with new solutions to problems. 12, learning new ways to think doesn't excite me very much. 13, I prefer my life to be filled with puzzles that I must solve. 14, the notion of thinking abstractly is appealing to me. 15, I would prefer a task that is intellectual, difficult, and important to one that is somewhat important but does not require much thought. 16, I feel relief rather than satisfaction after completing a task that required a lot of mental effort. 17, it's enough for me that something gets the job done. I don't care how or why it works. 18, I usually end up deliberating about issues even when they do not affect me personally. All right, so what you just completed was the need for cognition scale. Hopefully, if I was going too fast, you paused me so that you could play along. I went ahead and went quickly so that it wouldn't be super boring if you're just listening. So the need for cognition scale, first off, let's score it and then I'll tell you what it means. So in case you played along, the first thing you need to do is reverse the numbers that you placed before items 3, 4, 5, 7, 8, 9, 12, 16, and 17. So what that means is if you gave it a rating of 1, you're going to change your answer to a 5. If you gave it a 2, change it to a 4, 3s stay 3s, fours will be changed to twos, and fives will be changed to ones. So you're literally and physically changing your score. And that's because those items were phrased in the reverse way of the need for cognition. And so, in order to make this a scale that measures your need, we need all the questions to have been phrased as if the need is the goal. So, you're going to add up all of your ratings, and you'll use the original numbers for any item that you didn't have to reverse. You're going to use the new numbers that you just changed them to on those items that you had to reverse. And you're going to end up with a score that ranges somewhere between 18 and 90. So if you have a number that's something outside of that, you've done something wrong in your math. They loosely have created like categories. People who have a score that's greater than 70 are considered high on the need for cognition. People who are between 39 and 69 are considered moderate. And then people who are below the score of 38 are considered lower on this trait. So it's considered a trait. It's not, this has nothing to do with intelligence or working memory capacity or anything like that. It's a trait, it's a style. And so that's why we have these characteristics. Now, the thing about this scale is that it was intended to be used to sort people into groups for research purposes, right? So that we could maybe say, here are all the people who are high in the need for cognition versus those who are moderate and those who are low. And then, we do something else with them. We test their memory on something, or we assess their attitude on something or something like that. And we want to see whether people in the three different groups actually perform differently on something else. So it's usually used for research. It's not normally used for just, like self-improvement or self-awareness or something like that. But I thought it would be fun for you to take it. And so if you didn't do it, now that you see how it all worked out, maybe you'll go ahead and reverse this and take the scale. Because it can be interesting to know that people vary on this. Some people really enjoy puzzles and problems and, anagrams and just, some people really enjoy those kinds of things and some people really don't. And it's important to note where you are on this scale and then realize there are people in other parts of the scale who have different approaches to the world. And we should probably all respect our each other's, tendencies on that. People who know me outside of work, my friends and family, they accuse me of thinking too much and talking about things too much and wondering how things work too much and things like that. And I just happen to be really high on the need for cognition. I'm always thinking things. And I inherited it, honestly. My mother's exactly the same way. She is always wondering what's going on and always wanting to know what caused this and what that person's motives were, and just always thinking things like that. So it might be something heritable. It might be something that we learn at, our parents' knee. I don't know, but it seems to be a trait. All right, let's jump into the topic at hand, which is, problem solving. And let's start by talking about the different types of problems. There are some problems that have what we call inducing structure, which is a type of problem where our job as the problem solver is to discover a pattern that relates the elements within the problem. And so an analogy would be a good example of an inducing structure kind of problem. So here we have an analogy where child is to adult as acorn is to, and hopefully you're thinking oak or tree or something like that, right? An acorn is a baby tree, a child is a baby adult. So analogies help us to see patterns, right? Like you're supposed to notice that child is to adult. Well, there are a lot of things that it could be, right? It could be child is small, adult is big. Child could be, related to adult. There's a lot of things you could be thinking of, but when you see acorn coming next, now you're starting to figure out what the relationship might be. And so I'm realizing that it's a young to old. So acorn would be like young to what would an old acorn be? Well, that's a tree or an oak. So you have to figure out what the pattern is. So hopefully the analogy was pretty easy for you. I want to try something else, and you're going to be playing this by yourself. So there's no one to see your solutions or your attempt to solve things. We're going to play a little game called Petals Around a Rose. And I'm sorry, I need to close all these messenger things that might pop up while we're talking. I have a lot of things open. Let me close some classrooms. I got a lot of stuff going on here. So yeah. So here we have 5 dice. And I'm going to, let's call this the first roll. We'll just call this the initial roll. And I'm going to tell you how many petals are around the rose. Okay, and you're going to take what I'm saying and try and figure out what the pattern is, like what's causing me to say the numbers I am. So I can tell you on this set of 5 dice, there are 4 petals on the rose. All right, you can pause me if you want to look at it harder, but I'm going to roll again. Because with a new number, I'm going to apply the rule again, and I'm going to say that there are 8 petals on the rose in this set. 8 petals on the rose. I'm going to go ahead and zoom a little bit, give you a better view. All right. Roll again. All right, so now we have 2 petals on the rose. Okay, and I'm going to keep saying the name of the game because that's one of the things that might help you to induce, you might deduce the structure, right? So this is a structure that you're going to have to figure out. And so there are 2 petals on the rose. Okay, let's try again. All right. Again, we have 2 petals on the rose. 2 petals on the rose. All right, I'm going to go back and I'm going to tell it, whoops, apparently that rolled it again. So I'll tell you on this one, we have 4 petals on the rose. I thought I was going back to the beginning of the dice roller. Let's see if I can figure it out. How to go back to the dice roller. I'm going to reduce the number of dice real quick so that maybe it'll allow you to start figuring out what the pattern is if there are fewer dice. All right, so on this roll, there are 2 petals on the rose. All right, on this roll, we have 8 petals on the rose. On this one, we have 6 petals on the rose. All right, I'm going to reduce the number of, if you have it. So hopefully what you're doing is you're starting to think of possible rules that are guiding the determination of how many petals are on the rose. So hopefully you're sort of generating hypotheses. And as I give you feedback, you're rejecting or accepting hypotheses, right? So now I can tell you there are no petals on the rose in this roll. No petals on the rose. All right. On this roll, there are 4 petals on the rose. There are no petals on the rose on this roll. So generate hypotheses, falsify them with the feedback I'm giving you. There are no petals on the rose on this roll. All right, I'm going to get us down to 2 dice. Let's see. And for those of you who haven't figured it out yet, let's see if this will help you to narrow it down. There are 4 petals on the rose in this roll. There are no petals on the rose on this roll. There are 2 petals on the rose. One more time with just 2. And here we have 6 petals on the rose. All right, and then now if you haven't solved it yet, if you're not consistently predicting what I'm going to say, this might bring you to the solution by getting down to 1 die. All right, there are no petals on the rose. There are no petals on the rose. I like random rolling gives us twice in a row. There are 4 petals on the rose. All right, this is a good place to stop and just tell you what the rule is. The rose is a die that has a dot in the middle and then at least 1 dot on the side. So the die for the number 1 has 0 petals on the rose. 2, 4, 6, they don't have any dots in the middle, so they're always going to be 0 petals on the rose. So it's going to only be the 3s and the 5s that produce petals on the rose because they have a dot in the middle and then dots on the outside. So you don't count the middle dot, you only count the petals on the rose, right? So that's the rule for that particular problem. So it's a little bit tricky, a little frustrating when you're confronted with these kinds of inducing structure problems where you're supposed to figure out what the structure of the problem is. What kind of information did you attend to while you were trying to solve that problem? I have a lot of students who tell me that they were counting any doubles and thinking those were the petals on the rose. Or anytime a 1 came up or anytime a 6 came up, they thought that was something relevant. So a lot of times my students get very frustrated when I'm doing this in a live class. You can hear people going, no, when their hypothesis is blown again. And, they feel like nothing that they're trying is working. A lot of times in a face-to-face classroom, there's like this performance anxiety where nobody wants to like offer their solution and see if it might be right, because they're worried that they've drawn the wrong conclusion. So they've got performance anxiety. All this kind of feelings and all these kinds of experiences are very characteristic of solving problems, right? Solving problems can be stressful. Another type of problem is a transformation problem. This would be a problem where you're supposed to manipulate items according to some kind of rule in order to solve the problem. So math is a great example of a transformation problem. Here's another example, the 6 glass problem. So in the 6 glass, surprisingly enough, there are 6 glasses, and half of them on the left are full and half of them on the right are empty. And your job, your assignment, is to figure out a way to make it so that the full glasses alternate with the empty glasses, but the restriction is that you can only touch one glass. So how would you transform this cluster of 3 full and this cluster of 3 empties so that they become empty, full, empty, full, empty, full kind of organization? How do you get them to alternate while only touching one glass? Well, the solution is to actually pick up the second full glass in the group and pour it into the 5th glass in the row, or the second empty glass. So you've only touched the full glass. You pour it into the other empty glass, and then now you'll have full, empty with a few droplets in the bottom of it, full, empty, full, empty. These kinds of riddles, I guess you would call them, involve rules that govern your ability to transform the materials. Rearrangement of elements, all the elements are provided, but you have to figure out the correct way to rearrange them. So for example, anagrams. Here's a list of anagrams. I think I actually gave this list to you as one of your assignments to try out on someone else. So this should look familiar to you. So you're supposed to unscramble. That's what an anagram is. So the idea in the assignment, and then in this particular set, the way it was designed, is that if you were given the list on the left, bull, camel, skunk, mouse, zebra, and ape, because it's pea over here when it's vegetables, corn, onion, tomato, pepper, beet, pea, right? So it should be that your friend or relative unscrambles this first one as ape, if that's the list they were given, and the one who was given this list should unscramble this as pea. What I wanted to say about anagrams is that if the scrambled version makes a word like baser, it actually makes it harder to unscramble, because it's like, okay, it's a nonsense word, but it feels like the letters are in the right places and I don't know what to do about it. And I like this prep one can be very difficult for people to think of how to actually, and all you actually have to do to solve the pepper is move the R to the end. But it kind of looks like a word. And so sometimes people get stumped by how to rearrange what appears to already be a word, even though it's a nonsense word. So rearrangement of elements can be quite tricky. This is one that my grandfather used to love to do. I hated these. I can't figure out how to do them. Go ahead and launch. It's not launching. I don't know. I'm having the weirdest combination of things running slowly on my brand new computer, and then it kind of looks like there's no hyperlink there. So I'm just going to grab us some cryptograms really quickly in case you've never played them. My grandfather, like I said, he used to love these things, and I find them like just infuriating. So they're basically like trying to solve a hidden message, right? Something that a spy might have written, and you're supposed to unscramble it. So these cryptograms come in game versions. Oh, I happen to have grabbed one that wants us to get an app. But the basic premise is that you are supposed to, instead of just an anagram, this is not an anagram. You can't unscramble it and have it be a word. What you're supposed to do is figure out what the substitution would be to make these into letters that could become a real word. So probably Z equals A, probably. It could be I, right? Because the letter I is a word. But I'm guessing it's probably not I, because usually when there's a two-letter word, it's either, is, if, in, or it could be like to, to. So you start making some guesses and then you start substituting. So like here we have this word that contains a Z. Is it reasonable to have a three-letter word that starts with the letter A? Maybe. I feel like it's kind of in the running still. So you start just going after it and trying to find any irregularities, right, that allow you to solve it. It's infuriating. So that's about as much explaining about that kind of so-called game that I can do, because that is not a game, that is torture. But so that's the premise with an anagram. Isn't it funny? If it's something that you like and you enjoy, it's fun. And if it's something that you're not very good at or you struggle with, it's like, that's torture. All right, so the last example of a rearrangement of elements is the horse trading problem. In this problem, there's a little story where a man bought a horse for $50 and sold it for $60. He then bought the horse back for $70 and sold it again for $80. He keeps flipping this horse for some reason. So he bought it for 50, sold it for 60, bought it for 70, sold it for 80. What's the financial outcome of these transactions? Well, I don't know about you, but I'm kind of, I know for me, I'm a psych major, so math is not necessarily my strong suit. And then also the way that I balance my checkbook is, okay, so I bought him for 50, we're not going to count that outlay. I'm going to say I got $10 when I sold him, but then I had to use that $10 plus more I had to add a $10 to buy him again. But then I think I made $10. I think, right? So I kind of add and subtract as I go along. And I might, you might start off by saying I'm already in a deficit for $50. And so I don't know, I've maybe made 30 because 80 minus 50. So you might have these kinds of strategies for solving the problem. I think this particular problem requires a nice mathematician to explain to you what the correct solution is to the problem. So I'm going to stop here and you're going to watch this video that explains the horse trading problem in mathematical terms or accounting terms even. All right, I'll see you on the other side.